decided to save that $5, not give it to him, and then like,
I don't need love. I'm a joke.
I didn't get my graph. I forgot there was graphs.
What do you do? After like practice and stuff? What do you do?
I honestly just lay down and I just do nothing.
Does Carly do her homework and you just don't do it, or?
No, she does hers at her house and I just sit at my house and don't do anything. If it's not done, these 9 periods, it's not done. I don't remember working on homework this year. My group chat didn't do a lot of those last night. Yeah, I did that.
you finished? Yeah. I finished last period. I'm sitting there, totally not doing
Yeah,
anything.
Yeah, and guess who came to my aid?
What?
Nobody.
That's because you never help anyone else, and why?
Yeah, because that's why I'm in the group chat, is to ask.
That's a good point. He really never helps anybody else.
Probably should just.
Probably should.
You know, that hurt. Okay. I don't need nobody.
You're gonna be saying you'll need someone when you gotta get
A minute after you
All right.
get out.
Okay, all right, at some point today, page 188, that is due at some point today. Now, you also need your notes out. We're going to take a few notes today, just kind of a quick recap of what we did yesterday, to make sure everyone's kind of filled in here. Page 188 is due at some point today. I'm going to get that graded. And then what we're going to do today is we're going to start reviewing the practice guide, because we do have a test this Thursday in here. And I want to make sure that we start at least the first half of it today. So I'll put it up on the board once we're through this little mini review here. So it'll be pretty short, pretty sweet. I just want to make sure we understand what we did yesterday, in case you're gone or you're like, I didn't quite get it. Okay. So here's the idea. What we're on yesterday, if you didn't know, we intro just 1.5. It wasn't really anything new. We're still talking about linear equations. That's what you have to do in your homework, graphing lines. And writing equations, but what we talk about is how to apply it, like how to apply it to like parallel versus perpendicular. So that's kind of what we talked about. So here's the idea. The main thing that we really discussed were the different forms of linear equations, linear functions or equations. So the different forms, like we had point-slope form. That was one of the first ones we talked about. Point-slope form. Well, what's the equation for point-slope form? What do you remember?
y1 is equal to m parentheses x minus x.
All right. Now again, on test day, that formula will be on the board somewhere. I may not have it labeled, but it'll be on the board somewhere where you can see it. Okay. Now, how this works? This is your slope. This is the one of the coordinates that's on the line. These are just variables. That's all they are. All right. So we can come up with any equation as long as we have some information to go off of, like a slope, or we have 2 coordinates, something like that. That's what you have to do in your homework. We had slope-intercept form. Slope-intercept form. What do you remember about that form? Good. Y equals mx plus b. Now again, the y and the x are just variables. The m is slope, b is the y-intercept number. Now why this is important, why we use this form, if you have this equation, you can graph it really easily. If you have the graph and you want to go back to the equation, we go to this one. That's like the preferred one. That's the easiest. So that's kind of the idea. Then we talk about standard form. Okay, standard form is what we use for like algebra 2. Standard form is the one where you stack 2 equations on top of each other, and you solve by elimination or substitution. That's why we use standard form. It's great for story problems, that thing. But what's the equation that we use?
Ax
So that's standard form. Now, if you have two different equations and they're crossing each other like on a graph, having them written in this form and then stacking them is really easy to solve. We'll do those later. That's not our mission in this chapter. That's a later chapter when we get to like matrices and stuff. But that's standard form. And then the last one here was general. General form, basically the same as that. Yeah. You just want to equal 0 on the one side. And I know this seems weird, like when you bring this over, it should be negative. This number can be negative or positive. It's just whatever this is, you have 0 on the one side. That way, what we use this form for is when you factor things apart and you have it equal 0, you're actually figuring out the X-intercepts for that particular problem. So, like, for instance, you have 3x plus 2 equals 5. And what we're doing here, like if this is an equation, you would bring the 5 over here. Now I know it seems goofy, but you bring the 5 over here and make negative 3. And now I can factor this apart to see what would make this equation equal 0. Where would it hit the x-axis at? Right? So if I factor out the 3, that's x minus 1. And now it looks like what would make this thing equal 0 would be, the number 1, positive 1. And that's where, like, why we do that, this is the x-intercept number, where that line would actually hit the x-axis. So it would hit right here at positive 1. In fact, it would be a vertical line. The reason why I know it's vertical, like straight up and down, there's only one letter. There's not two. That's why it's going straight up and down. So that's why we have this one for factoring. You do it in a lot of algebra too. Maybe not that equation, but you do it for like for quadratics and stuff. Okay, but those are the different forms. Now, what we talk about is how to get like parallel lines, right? So if I give you an equation of a line, like y equals 3/4 x minus 1, right? That's an equation, right? That's in what form is that written in? Slope-intercept, okay? It's slope-intercept, and we can graph that. So, I mean, that's super easy to graph because I know the y-intercept is negative 1, right? Because that's my b number, so that's negative 1. And then the slope is telling me rise 3, run 4. And it's rise 3, run 4 from this point. So 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. And it always goes to the right. Even if it's positive or negative, it's either going up or down, and then it's always going to the right. That's just how I think of it. So here's your line. All right? Now, if I wanted to create something that's parallel to it, parallel to that, but it's going through, some random other point, all I really need is just the coordinate you want to go through. So somebody just give me a coordinate that is obviously not on that line. 4, comma,
-7.
okay, 4, comma, -7. I agree with that. That's probably a good coordinate. So 4, comma, -7. So we're going to try to create a parallel line that is going to pass through this coordinate, that 4, -7. So 4 over, -7 down is somewhere in this range. So that's 4, -7. And I want to be parallel to this one, so it's going to look something like this, right? Now, for things to be parallel, they have to be on the same plane, which they are. They can't touch or intersect, which they don't look like they appear to. But then what else? Same slope. That's a big thing from algebra 1. Their slopes had to be exactly the same number. So that means my slope on this particular problem, if I want it to be parallel, my slope has to be the 3 over 4. It has to be the exact same digit. So that's my fraction. So I'm rising 3, running 4, rising 3, running 4 from that particular spot. That's the idea. And if I want to come up with an equation for that, like the equation for the parallel line, I'd go to this one. Because I have slope and I have a coordinate that I'm going to go through. Because if I have the information, it's going to go back to this form. So that is, y plus 7, because it's y minus the negative. So y minus the -7. My slope is 3/4, and it's x minus the 4. Because I have to subtract x. Now, if I want to get this to a different equation, that's my parallel line in black there. If I want to get to like a different form of this, all I have to do is distribute. So if I distribute the 3/4, that's 3/4 x. 3/4 times -4 is -3. How I know that? The 4 would cancel. So it's just -3. And then the 7's over here, and now I can drag the 7 across. So that's, if I drag the 7 across, I would make 3/4 x minus 10. So it looks like I'm going to hit negative 10. It's actually really close. That's kind of where the line's going, like that. And again, most people can use the slope here. I'll go up 3 over 4 up 3 over 4. Okay, do you see how like easy it is? Once you know like the different forms, how to go from like one form to another, or how to take information and go off of that. Now those are parallel. When we talked yesterday about perpendicular, that's a different story. Okay, so perpendicular now. So somebody give me an equation. It can be really any form you want. But just give me something that has some simple numbers. 7. Yeah, please.
Well,
You give me your random numbers. I need an equation.
well, you need an equation? Oh.
Yeah.
What kind of equation?
Anytime. Over there. Just something, one of those.
Y
Y
equals
7
X
x
plus 17.
17. Okay, so there's an equation. Now, I want to be perpendicular to this thing. I want to be perpendicular to, so I'm going to perpendicular line to this thing. And now I just need a coordinate to go through. So that line is really high. If you don't know, it's at 17 above the x-axis. It's in the y-intercept at 17, and it's going up 7 over 1. So it's really kind of steep. But I need a number to go through here. Where do I want this line to be? So what do you think? Give me a coordinate that you want your perpendicular line to go through.
7.
Comma.
Oh.
12. 7 times. Really high. All right, so let's graph this thing. Let's take a look at what this thing looks like. So I'm going to graph the original one, and then I'll try to graph the perpendicular line roughly. Okay, so 7x plus 17. So 17 is way up here. 12, 13, 14, 15, 16, 17. All right, so 17 is where I'm going through. It's going up 7 over 1 or down 7. 1, 2, 3, 4, 5, 6, 7, and over 1. 1, 2, 3, 4, 5, 6, 7 over 1. All right, so here's my line. Okay, so there's my line. That's the original line over there. And I want to be perpendicular to this thing. And the coordinate you guys picked was 7, 12. So 7 over 12 up. And I want to be perpendicular to this thing. So it's going to look something like this. Something like that. So it's like a 90-degree angle. That's what perpendicular means. So the big thing is, I can go to my equation, my form, right? So it's going to be y minus 12, some slope here, we'll fill that in a second, x minus 7. Because that's the coordinate I want to go through. But what's my slope going to be for perpendicular?
Reciprocal and opposite.
Yeah, reciprocal and opposite. That's kind of what I heard. So what's the reciprocal and opposite of that 7x? Negative 1/7. You flip the 7 over, so it's 1/7, and you make it negative. So that means from here, I'm dropping 1, 1, and 7. Or going up 1 and over 7 this way. So it actually hit right here. So it actually hit it 13. So it's actually really close. Okay. Questions, comments on anything that I've done here for parallel and perpendicular? The reason I brought this up, I just thought it was interesting. It basically uses exactly what we've been learning on this page 188 stuff, and I thought it was just kind of a perfect fit. I didn't want to give you homework on it because it's basically the same homework, but I just thought it was interesting. It's kind of, there's kind of easy problems, but they really test your knowledge, like, do you understand what an equation is, and do you know how to graph it? So that's kind of perfect. So, all right, so any questions with what we did yesterday? Kind of a fill-in, just kind of get back in the swing of things. I will test you on one of these, like on parallel and perpendicular, because I think it's a perfect wrap-up to what we were doing. It's perfect for what we need. All right, I'm going to leave that on the board. Let's go to our practice guide now. So if you have your practice test, I'd like you to take it out. If you have not received one yet, they look like this. I handed them out, I think, last Thursday or something like that. It looks like this. Or last Friday. Anyone need one?
Yeah.
Okay. It's like I had too many. Okay. All right, so let's pop up your practice test here and let's talk about it. All right. Let me get rid of some of this stuff. All right. So, practice guide. If we scroll through this here, we'll look at all the numbers of problems. So, this problem number 1, you have a graph. I gave you kind of a blank graph, so you can kind of make your own axis where you want to put it. Because I know some of these numbers, like some of the numbers are pretty big. You know, you're making, you want to get up to $150 at some point. That kind of thing. All right. So the numbers could be big. You may want to jump out at 10s or 20s or something like that. Or maybe 50s, I have no idea. All right, so we have to create an equation and figure out the intercepts. All right, number 2, you're using the table here to answer these questions. You know, you're going through the origin, does it cross the y-axis, x-axis, okay, that type of thing. 3,
May I have your attention, please? Joe from Athletico is here. If there are any any freshmen and sophomores that need to see him, please go down to the locker room area at this time. Again, freshmen and sophomores that need to see Joe from Athletico, please go down to the locker room area at this time.
all right, number 3, we're finding domain and range. These are the ones I'm checking for your interval notation. And are you using brackets or parentheses? Are you going to do infinity or not? I'm trying to pick kind of an easy graph. The last one always gets people, like find the missing function values. That's this time. Like when you plug in a -2 into this function, what answer does it spit out? When you plug a 2 in, a +2, what answer does it spit out? Those are like, that's your last question. Okay, so I just put them over there so you can see that. 4, you know, you're graphing this as a piecewise function, so you have to graph the top one, you have to graph the bottom one. The big thing I'm checking for is like, do you have open circles or closed circles? Are you at least graphing a couple of points to see where it's going, especially like the top one's a curve. Then you have to tell me the range, the intervals, whether it's increasing or decreasing. That's the big thing I'm checking, the interval notation there. Or you tell me the min and max. And I just ask explicitly, does that have an absolute, does that have relative? Number 5, you have to use the data from the graph here. You have to plot it. So you have to plot some data here on that graph. So you know you have a certain number of years. You have certain values here. So you can set your list however you want it. Do you want to start here with like 50 and kind of work your way up? Do you want to go by 10s or something like that? And you just have to plot it on the graph, and then you have to answer a series of questions about that. So I mean, the first question says create the scatter plot. It kind of this problem really walks you through like what you need to do with the interval. Okay. Then draw a line through 2 points. Then we do a rule and stuff. Okay, you'll have something like that on the test. It'll be something easy. It's not overly difficult. You just all they're asking you to do is just take data, put it on the graph, answer some questions about it. Okay, find a slope. That's it. Find the equation of a line. So it's very easy stuff. 6, you have to do the differential quotient. So I said this is going to be on the board and it'll be on your practice guide, okay, and the test. So this is the formula you're using, but this is the function you're actually going to use in here. Okay, that type of thing. Yeah, I would not expect something that hard on the test. I'm just going to put one of these on there just to see if you know what you're doing. 7, you know, find the line that's perpendicular to the one passing through this certain situation. So it's perpendicular across. Because this is a perfect mixture of what we've been learning about linear equations. Equations of lines, that type of thing. Okay, so there's 7 problems in total. Okay? My goal today is to go through the first 3. First 3 probably. And then tomorrow we'll do the next couple. So we'll just kind of walk through these as best we can. Alright, so let's start with this one. Okay, so Bill works for $10.25 an hour. Okay, so that's his hourly rate. He makes a total of 33% is deducted for insurances and whatnot, and he's trying to save $150 for a new pair of Beats headphones. How many hours must he work to obtain a desired $150 if he's saving all of his remaining salary? Okay, so after the taxes and insurances. So if 33% is deducted for taxes and insurances, what does that leave him to save? 2/3, 66%.
Yeah.
Right, 66% or 67% if you want to do it that way, will be what's left for his salary. So how this function works, like what's the equation? Is, this is your function, whatever that function is. That's just a big fancy way of writing y. So that's actually just your y value. And then over here, you're finding 66% or 67% of his hourly rate. Well, he's making $10.25 per hour. So if you take how many hours he works times this, that'll be his price, and you're saving 66% of like his hourly rate. That's the idea. I mean, that's it. And now we're going to probably start at 0. So this would be 0, and this would be like his hours of work, and this would be like the money he's saving. So maybe if he wants to get up to 150, so maybe we want to jump by 20s, or maybe you want to jump by 10s. I have no idea. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, or 10, 20, 30, 40. Yeah, let's go by 10, 20, 30, 40, 50, 60, 70, 80, 100, 10, 20, 30, 40, 150, 160. And what this is going to do, this will actually give you the money that's left, what he's saving. So what we're trying to look for is when will he hit this magical 150? That type of thing. So we have to create the equation, which we already did. We have to find where he's going to hit his desired money. That's question number 1. And then eventually we'll have to figure out the y and x-intercepts. Well, I can tell you where the y and x-intercept is. Where are you going to hit? X and y intercept, you better hit 0, 0. You have to start with 0 money. And you got to work your way up. That's just common sense. So I'm going to start with 0, 0. That's my x and y intercept. It's the same number. Common sense. I start with 0 money, and you're going to work your way up as you work. Now, how many hours? I have no idea how long this is going to take me. I don't know if I need to go by 1s, if I need to go by 5s. I have no idea what we need to jump by. But at some point, I need to figure out when will I hit $150. Okay? If I multiply this by 10, 10 comes in 100, and okay, so maybe I need to jump by 5s. I have no idea. Or 3s, I have no idea. Let's jump by maybe 2. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. I have no idea if I need to go out that far. I just gave you kind of a blank chart to see kind of where we're going. And now this is where you just use the calculator and you can kind of calculate. You plug in the 2 here, and for my x, calculate that, take times 67, and then plot the number. Maybe it's here. And then do it again for 4. And then when you get up to about 150, wherever that's at, I have no idea. You need to figure out kind of roughly where that's going to be. Oh, it's going to be between $14 and $16. Maybe it's $15. Okay? In fact, you could do the reverse thing where you just plug 150 in here and figure out. But that's the idea. Okay, on your test, what you should expect something like some type of real-life situation problem where it's not overly difficult, just something where you have to plot it. You plot your data and you come up with a number. It'll be some, linear function. It's going to be some type of line, so wherever you figure out where you're going. You'll need a calculator. I have some up here if you need it. You just have to graph it. Does everyone understand how to attempt this first? I'm not going to make it difficult. Just, can you do it within a couple minutes? It just takes time to type in some stuff.
Is the x and y always going to be 0?
On that particular problem, yeah. So, how this could be different. Maybe I say that, who's this? Bill. Maybe Bill already has $30 saved. So now you have a new y intercept, right? So now he's starting at 30 for the y-axis number.
And like percents, or go with like your slope.
Yeah. So when you multiply this, this number times that, that's technically your slope. That technically is what it is. I don't worry about slope. I just plug in coordinates like one at a time, and then just plot those dots, and just kind of see. Can I get to $150 pretty quick?
If only I was like, let's try to do the equation.
Oh, yeah. So the equation is just, hourly rate or something like that. And then maybe you're saving 50%, so half your salary. That's all you think about. how I picked this problem, it was one of the story problems from the first section where you just had to plot linear equations by just plugging in numbers, one number at a time. That's all it was. Because that's what you have to do in the first assignment. You plugged in like -3, plug in -2, plug in 1, plug in 0. You kept plugging in numbers, and you're just plotting where the dots are going. That's what you're doing here. All right, questions, comments on any of that? You'll have to think about it a little bit for the equation. It's not going to be hard, but it's not going to be just like, oh, it's exactly linear like this, even though you're saving 67%, 30% gone for taxes. You have to do a little bit of thought. But not. All right, let's move on. Okay, number 2. All right, number 2. Okay, all right. Now, you probably recognize this problem. This is exactly from the homework as well. It's a table of some sort. You have to answer a series of questions about it. Okay, so what you have to do first, you have to figure out which equation out of the 4 represents y1 from this table. Now, how do you know that? This is how I would do it. These are your x numbers. These are the y numbers that are spitting out for y1. Here's how I figure it out. I just take each of these x numbers one at a time and plug them in here and see if it's spitting out the right y number. So, if I plug in, let's plug in the -3 here. So -3, that's my first x, right? So what's -3 times -3? 9. All right, so far so good. That's good. Let's plug in -2. So -2 times -3, 6. Okay, so far so good. Let's try a different number. Let's try like up to -1. Or let's try 1 now. 1 times -3. Oh, all right, so it looks like it's this one. I mean, it looks like it's hitting almost everything perfectly. It's the first one. Let's see if it's any of the others. If I square it, -3 squared is 9. All right, -2 squared, it's not 6. So it looks like the square thing doesn't work because the 2 failed. That one won't work because it's squaring again. This one, 2 minus a -3 is 5. That's not 9. So yeah, it had to be the first one. It had to be letter A. So that's how I do it. I just plug in one number at a time and see which equation it's going to be. And you're looking either y1 answers or y2 answers. That's just what your homework did, right? All right. Does this y1 pass through the origin? How do you know it passed through the origin? Is there a coordinate 0, 0?
Yes.
Yeah, right there. So yeah, that's a yes. Move on. It's just short, simple. Does it, cross the x-axis? Yes. So you have to give me the x. You have to give me at which points does it cross the x-axis? So you have to give me the coordinate where it actually hits. The big thing I want you to be careful of: are they asking for y1 information or y2 information? That type of thing. So it's a yes/no question or ask for points. Just read the question. Don't like go so fast because maybe like there might be 2 answers. Maybe because I know on the bottom question it asks like, do they cross? Do they intersect each other? They might intersect twice. Like how I know that they intersect? This is one intersection right here. Right here. They have the same x number, same y number. That's an intersection they touched. Is there another one down the road? No. So that's your answer. So the spot where they cross would be -1, 3. That's where they cross. They intersect. That's the bottom one. Does that make sense? Like I'm looking at that? They have the same x number but the same y number. It'll be something like that. I'll give you a table. Ask you some simple questions. Alright, so now comes the tricky ones. This is the ones that I've noticed that from those top quizzes we took. Can we figure out domain and range correctly with the right brackets and symbols and stuff? Okay, so functions domain. When you look at that graph, what are the x numbers I'm allowed to use on this problem? This is problem number 3. What x numbers am I allowed to use? Infinity. I can go from -infinity up. The reason why it's infinities, like both directions, because there's arrows. I mean, it's literally going forever this way, going forever that way, because it is tapered outwards, so it's going to keep going. It's going to boat outwards. So my domain, my x numbers are from -infinity up to positive infinity. Now I'm using parentheses. Infinity is not a number. I don't include it. It's a direction. Okay, what about range? What's my lowest number for range? -infinity. Okay. What's the highest number for range? 4, and I'm including 4. where it stopped. It peaked. And again, for those, I'm looking for like, if it's really difficult to look on the graph, just give me a approximate.
May I have your attention, please? If there are any juniors or seniors that need to see Joe from Athletico, you can go down to the locker room area at this time. Again, juniors and seniors that need to see Joe from Athletico, please go down to the locker room area at this time.
Okay, X-Intercepts. How many X-Intercepts are there in that picture? 2, list them off. You can just give me the numbers, you can give me the coordinates. I don't care. But if you're going to give me the coordinates, you better put them in the right order. Okay? So if you're going to give me the coordinate for the X-Intercept, you better be telling me like -3, 0, put in the parentheses, that kind of thing. If you're just going to give me both numbers, like both intercepts, just write it like this. Like -3 and something else. That's what I'm looking for. Y-intercept, same thing. All right, now the bottom one, I don't know why this always gets people. Let's talk about this bottom one. I'm evaluating the function at 2 different spots. That's what they want. Like, figure out where the values are. So I'm going to do the first one. F of -2. So by -2 on the x-axis, what's the value is it spitting out? It's roughly about right there-ish. Maybe a little bit higher.
Yeah, I was gonna say it's like
Maybe 3.5. So if you're in the ballpark between 3, 3.5, I'll give it to you. So this answer would be roughly 3.5. Let's say. What about 2? We have 5. Done. Move on. If you're finding that number on the x-axis, whatever number I'm telling you to put into the function, and you're telling me the y answer that the graph is giving you. Does that make sense? And if there isn't one, just tell me it doesn't exist or something like that. Maybe there's an open circle there that doesn't have a number. If there's 2 numbers, tell me. Maybe it's split. Maybe it's not a function. So that's what I'm asking for. I'm asking you to evaluate the graph. This is what you'll have. You'll have some type of picture. I'll ask you a series of questions about it. All right. Tomorrow, we will most definitely talk about number 4, because we have to talk about piecewise functions, know how to graph them, know how to find, increasing and decreasing, and where, the x-intercepts are, and is that a min and max. We'll talk about number 5, where you have to, plot your data. That's kind of like, number 5 is a lot like number 1, where you just have to set up your own graph, plot the data, and then answer a series of questions about it. 6 and 7, kind of same idea, you're graphing lines, that sort of thing. Okay, questions, comments? Okay, we'll go through the rest of them tomorrow. Today, you have the rest of the time today to kind of work on this. Definitely work on number 1. Try to get that wrapped up, because I know you got lots of data points there. And then if you can, try to finish up 2 and 3. Maybe start 4, so that tomorrow we have some ideas how to do that one. We'll probably spend the most time tomorrow, probably on number 5. Just because you have to plot some data points yourself in the graph. 37. So you have about 7, 8. Okay, when's our test in here? Thursday. So make sure you're prepared. probably accurate as 0.67, but you'll be in the ballpark.
Where are you going?
For what?
Student night?
Student night?
Hey,
Tomorrow's student night, guys.
I don't think I work tomorrow.
I'm hungry. Yeah, sir, you're a church leader.
I don't know what I'm not gonna lie. I don't know if we're going uphill or down.
I'm not gonna lie.
Less than
As we go uphill, until people start talking. Yeah.
Like Derek.
Like we start off on a solid and then it just
And then you got Durger, who just does his own thing.
Durr just laughs the whole time. You're always laughing at something.
You guys do suicide. This is weird.
What?
What, you don't want to come to student?
No.
I cannot believe you. I really can't.
ATO. Remember the last 2 student nights that we've had?
What?
They haven't ended up any of us even students, right?
No, it's you gotta put it at like half. It's negative half. Because you take one and then 0. Obviously it's just gonna go negative. And when you do negative 1, it's still gonna be on the negative half. And that's gonna be closed, yeah. And then when you plug in 2, the squared is 4. And then 4 times negative half is negative 6. And then I do my 7. No, it's over 2.
Oh yeah, because that's what year 1 is going to be.
Piecewise functions are curves, right?
Piecewise functions, some of them are curves, but they have an expert on curves.
Oh,
Alright.
Part of curves.
Yep.
I know.
Wait, hold on. If I put a 1 in here, I don't actually put a dot at it.
No. When you put in a 1, that's just where it's gotta be on the X. That's just like coming out.
oh yeah, yeah.
No way.
Mr. Ward?
Yeah.
So this piecewise functions, if there's not an X squared, do we draw the arrow both ways? Like both directions or something?
This is just a line.
Like it's starting at a certain point, it's gotta be greater than or equal to something.
So it's got to be greater than equal, it's going one direction with an arrow, and then every other direction with an arrow.
So not both ways.
So it's not both ways?
No, because you're
Not both ways. You're only allowed to go up.
Negative.
You know what, Connor? You don't. One of the references. Phyllis.
Oh,
Barrels.
self everything green, so here's on hold.
She was straight up wrong.
Oh, the first dot is a multiple.